you still cannot sit for long, eh?
Not for a long time, but it's okay. It's better now. It's better.
Okay, okay. So you're still young.
Alhamdulillah. Not like
Okay.
50 years is not young.
Young in the heart.
Inshallah, inshallah.
Your your spirit is young.
Maybe, maybe because the ambition, because I'm still dreaming to improve myself and to get more from this life.
Inshallah, inshallah. Okay,
Yeah.
you know, I, the proposal that I read from your side, yeah. So,
Yeah.
though you know, it's a bit too early to give to provide that kind of proposal,
Mhm.
but because normally our workflow is like this, you know, we first draft the POM table, okay, and then after that, we'll do the literature review and discuss few key papers. You know, you review the key papers, but at the same time, in our meeting, we should discuss the key papers, and then only we can finalize our problem statement, objective, and methodology. Once we have like an agreed version of the PM table, then we go for a complete proposal. Yeah, but seems like you are. I mean, you already right. Like you know, you include all the methodologies, detailed methodology of the proposal, which is maybe it will be useful at some point. But now I think we should focus on the finalized objective and scope. Yeah. But
Yeah.
if you open your proposal, if you share your screen with your title, you know, reflects what we discussed in the last meeting, which is quite a while
Exactly.
ago. Yeah, yeah.
Exactly. Yeah.
Can you share
Yeah. Of course.
your proposal with the title,
Okay.
and then you know we can just you know uh, try to brainstorm the objective with the uh, problem statement. Okay,
You
so
see my
the keywords
screen?
that I saw here, yeah, yeah, the keywords
Okay.
that I saw here is on carbon capture, okay, techno-economic assessment,
Mhm.
uh, and then yeah, just stay on the title page. Just stay in the title page.
Yeah.
Yeah, so we also have hydrogen co-firing. Yeah,
Right.
uh, yeah, and the only one that we don't have here is the um
I
you
thought I include
know,
everything.
yeah, yeah, yeah. I mean, the you know what we discussed last time is basically
You told me.
including
Yes.
because we already agreed that hydrogen co-firing will not be feasible unless we have on-site production of hydrogen, okay, which may come from hydrogen cracker,
Yeah.
or it may come from steam methane reforming, or it can come
I
from you
assumed. I
know.
assumed. Doctor, I assumed that I will got the production. I mean, I will got the hydrogen ready. I didn't talk about the cracking.
Yeah, yeah, yeah. But I think since we are talking about techno-economic assessment, we
Mhm.
better put a complete picture in place so that we can see all those angles, including the source of hydrogen. Yeah. If
Okay.
we decide the source of hydrogen to be independent variable, then we can study, you know, the feasibility in terms of sourcing hydrogen from steam methane reforming, from you know the what do you call it, hydrogen cracking, or it can come from the electrolyzer, electrolysis.
Sure.
Anyway, do you have like the problem statement, objective, and methodology table in one page so that we can
Doctor,
see
doctor,
what you draft here?
Doctor, first of all, the problem is, according to my experience, I have to focus about, or I used to think about the subject, all of it. I mean, from all the aspects. That's put me in a bigger problem, which is the size of project will be very big. And in this case, I'm facing another problem, which is the time period of the PhD. It will cover these all these aspects, because last time when I show you the first version of proposal, you said it will not match the PhD level. That's why we need to enhance it by adding the techno-economic and the carbon emission and the NOx emission, also the carbon capture. But when I have made some search about these things all together, it will be a very big project. So I'm afraid I'm falling in this problem.
Yes,
The
I mean,
time for the PhD.
if we do CFD for all of it, then it will be very big, right? If we maintain
Right?
ourselves within techno-economic analysis, because it's very common that techno-economic analysis is done for the whole power plant, including the hydrogen source, and some of them combined with renewable energies. So techno-economic analysis can go very far. I mean, can cover a very wide scope, which is actually fine in terms of timeline. But
Mhm.
obviously, in terms of getting contribution to knowledge for PhD, coupling with some kind of CFD will be quite important. So, techno-economic analysis for hydrogen co-firing, I think that's why I want to listen literature review from you. Who has done it? What kind of techno-economic analysis they have done? And then we'll see how we contribute further. Yeah. So that's why let's to begin the discussion. Let's have the objective on one page. Yeah, which you already have on one page, but we just need to put it in a table form so that we can put it side to side with the problem statement and methodology.
Mm. So in this case, you mean that the object, you mean this
That's
page?
fine. Yeah. Yeah. This page is objective 1 until 3. Yeah.
Yeah, three and
Okay.
four
Okay. You have
objectives.
4 objectives. Okay. Then you
Yeah.
put 4 objectives for now. Then we need to put problem statement next to it. On the left, put problem statement. On the right, we should put methodology.
Sorry, I didn't get you.
On the left of the objective, you put the problem statement, and on the right, you put methodology.
Yeah, yeah. You
But
mean
you haven't done it. Maybe you can just copy. You can copy this table and then just edit the table accordingly. In each of the problem statement on each row, you put a specific problem statement addressing objective. The objective in particular row.
so let's be direct. So let's be focused. Do you mean you want me to make a table containing the objectives and in front of it the methodology for this objective, right?
Yes.
Hmm. Okay, okay.
Yeah.
That will be a new table.
Uh, yeah. In fact, you can just copy this table and copy them to a new document. Then
Mhm.
we can do right away. We can just do right now. Very
Okay,
simple.
but I wanted to, now you remind me by something. The table which I have done it for you. Is that what you mean? Is that what you want?
Which table?
I have sent you the table, the example for the proposal, for the yeah, for the proposal, for the, where is it? I send it to you. Shared. I sent it to you last time.
Yeah. I think you send me the literature review table. Uh,
Not
we're not talking about literature review table. We're talking about the POM table, because you were not there in the last meeting when we
yeah,
discussed this.
but I have done it. But I have done it. I don't know where is it exactly. Last time you sent me a link about the POM table, and I have fill it and send it to you, right?
You have sent it through this channel. Then you can press Control F. Then you can search for
Control F.
POM, and maybe Control F. You
POM.
can search. Yes. Yeah. Here.
POM.
Yeah. Just click that training kit. Click the training kit.
Sorry, training kit.
Yeah. Click there. It brings you to the another Google Drive. Okay. Now, you should click on the top right hand side corner. Open in browser.
Open a browser. Yes.
Then from here you select writing.
POM.
No. Select writing. Scroll down.
Scroll down.
Writing thesis.
I think this is
Okay. Writing.
writing.
Yeah.
Writing.
Then POM. There. There's
Oh,
POM.pdf. Okay, this is how the POM looks like. So list your objectives, and then what are the problem statements pertaining to that objective,
I have
and then
sent to
what's
this
the
one.
methodology.
I
Yeah,
have
so
sent to
that this is the table. This is the table that I want us to see now and then finalize.
I have sent to this one, Doctor.
Yeah, so I don't know where they are.
No problem. I will send it again. I will send it again. It's already done. I have done it here by the Google form, the form here. I
Yeah.
don't know why it's not appeared. No problem. I will go back to Teams. I will search about it, Doctor. I'm not going to lose the time. Or if you want to see it now.
Yeah, because that's the one that we need to discuss in detail. You can just copy and paste quickly your objective, and then put the methodology and problem statement on one page. Then we can discuss it too.
Maybe I can find it now. I want to go to the root. POM, right? That's it. That's it. You see? Doctor, you see
Where
it?
did you post this?
I
Oh, you
posted.
posted in the wrong channel. You posted in the channel on our collaborative proposal. Yeah, so that one is the different channel. That one for poly generation, that is different channel. Yeah, that one's supposed to be meant for our other proposal, working with the rest of the members.
Okay, so I will
This one
download
you
it
should
now.
post. Let's download it and post this in
Yeah.
HSH. Yeah.
Okay, save. Share or save?
Yeah. Just click file.
Style? File.
Click file. Yeah.
Share?
And then
Create a copy.
create a copy. Yeah, create a copy. Download a copy.
Download a copy. Download a copy. Download. Okay. Okay, that's it. That's it. Now I have to share it and our channel, right? Which is HSH, right?
Yes,
HSH.
exactly.
Yeah, and now I have to share, upload files. Open. Now it's shared. Okay. You can see it or not?
Yeah, yes, I can see it now. You have to rename it. Rename it to POM.
Rename. Rename. POM, right? That's it. Done.
Yeah, just click the triple dot again. Oh, the triple dot. Click the triple dot, please.
Sorry?
Click the triple dot. Just now there is a triple dot next to the file name.
Yeah, triple dot. Triple dot. Now share, right?
Okay, and then make no. Make this a tab.
Make this.
A tab. I think the fifth from the top.
This a tab. Make this a tab. Yes, I have done.
You click it. Yeah, ready?
Yeah.
Yeah. So now it appears in one of the tab over there. So we can always have it easily. Yeah, it's always there.
Okay. Done.
So now you can open the file.
Okay.
Yeah. So now we need to look at the first object. Yeah. Now you can try to brief me what are these objectives and just simplify it further. What you mean by what you mean by this objective number 1 until 3?
Okay, good. But now it's clear. So we can go with first column, which is the problem statement. You can see this is the primary objective because I have separated to primary objective and four sub objectives related to the questions, because I have informed you previously that I have main question or primary question and four sub questions. Okay, so for each question there is an objective for the primary and for the sub. For the first one, the primary objective, which is the hydrogen co-firing and gas turbine, faces challenges like combustion behavior challenges, increased NOx emissions, and the cost and cost. A framework combining CFD and techno-economic analysis and the need to optimize operating conditions. So the objective is, or this is the same primary objective, sorry, that was a problem statement. Then the objective, then the methodology. So is it okay?
Okay. To have a sub objective is not a usual practice.
Sorry.
To have like sub-objectives. It's not our common practice. Normally, we just have the primary objective,
Yeah.
3 of them or 4 of them for one PhD project. Okay.
You mean all of them as a primary objective?
Yes, that's the normal practice. Okay, I think what you haven't explored, can you go back to the training folder?
The training folder.
Yeah.
You know,
Later on, you can put a bookmark in this training folder so that you can access it easily later on. Because in there, I always refer you to our reference thesis. Yeah, reference thesis will be
that one?
yeah, the reference thesis. Yeah, go to the training folder.
This one?
No, the training folder.
Training.
Yeah, the training folder where you fetch the template of POM table before.
Training folder. Where to find it?
You go to
That's it, right? Have to download the training folder training, right?
yeah.
This one?
Yeah, but not this one actually. You can go to the NZ10, NZ10 Microsoft Teams, the team for NZ10.
That's the NZ10.
Just go to NZ10 Teams.
This is the NZ channel, right?
This is not NZ10. Go to NZ10. Click NZ10 over there.
Okay, NZ10. Yes.
Yeah, and then you can go to the training kit, the tab called training kit on top. You don't have to scroll up and down. We have a tab there where the tab is called training kit.
Training kit.
Yes. Okay, now open in browser. Click open in browser.
Okay, done. Writing thesis?
Okay, so this is go to thesis.
Thesis or writing thesis?
Yeah, writing thesis.
Okay.
And then writing.
Okay.
Yep. And then oh sorry, it's not in the writing. No, not this one. First of all, I would like you to bookmark this training folder in your browser. Can you bookmark it?
Bookmark.
So easy for you to access it in the future.
Okay.
Not this one, not writing thesis, the training one, the main folder of training. Click the training folder.
At the training folder, right?
Yeah, bookmark this one.
Okay. Done.
Okay, so you have it. You next time, whenever I say training kit, you just go to your bookmark. It's easy, yes?
Right.
Okay, then you go to the references.
References, okay.
Okay, not this one. Go up again. I'm trying to look for the thesis.
Can we make a search for thesis?
Can you click template? I'm not sure. I think maybe in template.
Templates. Okay, templates.
Not this one also. Okay. I tend to forget where it is. Training. Click training again. Maybe you can just search in the drive for thesis.
Training. Thesis. Research paper synthesis for thesis.
Can you click writing thesis again?
Writing thesis. Writing thesis, right? Smart tools.
Just click that one. No, click the one at the bottom. No, not this one.
This one?
Click the one and no, not this one.
Okay.
Just click writing/thesis. There is a folder called writing/thesis there.
Okay. Slash thesis. I went to the folder.
No, the folder is there. It's in on your screen. Can you see it?
Yeah.
Yeah. It's on your screen. Okay,
Yeah.
just 1 second. Let me think. I think references. Click references.
References.
Here you go. Okay. So these are actually the past thesis from. Oh no, this one is not thesis. Sorry. Go up again. Writing.
Okay, writing thesis. Right?
Click writing again. The writing folder there.
Done.
Okay. I don't know where is Dr. F1 thesis is not there. Let me just forward it to you then.
It's 1 o'clock.
The thesis is. In a second.
It's complicated, that team.
Yeah, because I mean, it's complicated if you haven't bookmarked your browser. But hopefully, it will keep things somehow recorded. It's just, if I haven't looked at it long time, I tend to forget. Yeah.
Yeah.
Right. Let me see. I have it here. The thesis. This is signature page. But once you get this example of thesis, then you can learn the general format from there. Yeah.
You mean it's a template, right?
It's not a template. It's a real thesis. Real thesis by Dr. F1. Who was under my supervision before, right? And from here you can learn quite a few things. I think someone may have removed those folder before. I don't know who removed it, but we used to have it somewhere there.
That's one of the problems which I have in the Google Drive. Everyone can remove or add something.
No, actually, not everybody can remove. I don't think you can remove anything from there. We give privilege to remove by our data manager, but then sometimes even our data manager make mistakes. So, it happen like that. So now I send it in your channel. Can you see it?
And my channel.
Maybe it's a bit slow because you have to.
This one, overall UTM format. Something went wrong.
Ada pandai yang mana buat sini? Temanya? Ya itu. I think it's uploading now. Yeah. Maybe it will take some time to reach you.
The file name is overall UTM format.
But anyway, the objectives. Yeah, this is the one. This is the one.
Okay, I think it's uploading.
Can you see?
It says
Can you
something wrong.
see that something is wrong? I just wait for a moment because it takes some time. I think it's uploading now.
No problem. Doctor, I wanted to ask something about I have some questions. First of all, I think I need to reduce the size of the work because it address many aspects, and I think it will put me in this problem that I have mentioned to you, the time of the PhD. So, do you think, according to your experience, do you think all these aspects can the period can cover these aspects of the project?
For TEA analysis, yes. Even
Okay.
if you want to make it larger than this, it's okay for TEA analysis. For
Yeah.
CFD, no. For CFD, no. You cannot do the whole thing CFD.
Mhm.
But for TEA, you can even increase the scope further.
So we will focus about the TEA,
Yes.
techno-economy. Okay. Does that mean that I have to change the references?
Now I finally found it. It's there in the training folder. It's actually under this UGP starting module. You were there in the writing/thesis folder just now, and then you just click UGP starting module. It's there inside this folder. Yeah.
Where is it?
And you click your browser again, your bookmark.
On my bookmark. Writing or training?
Yeah, writing.
Writing. This is writing.
Okay, just click UGP starting module.
UGB starting module. The first one or the second one?
Yeah,
Two
whichever is
folders.
fine.
Two folders.
They're the same thing.
Same?
Yep. Okay,
Higher
so
public
thesis is there.
thesis.
Yeah, so here just click Talha thesis, right?
Talhali. This is
Okay,
okay.
so this is an example of thesis. This is computational work, which is I think quite good. Similar to what you have. You are working on. You are doing computational also. So you can see the objective page is something like that. Yeah. In chapter 1, you go to section on objectives 1.2. I think this is a master thesis. Okay, yeah. So they have three objectives here. So this is how the objectives, and then you have the problem statement and methodology. Yeah.
Okay. Download it. So this is for PhD or masters?
You can check the front page what it says because Dr. Talha did both his master and PhD under me. I can't remember exactly which one is this.
Okay. I think in the main in the first page, right?
Yeah, what they say over there, is it master? Further down.
Modeling and flame sensitivity of carbon nanotube and investigating diffusion flame.
Okay, this is for master actually.
Master. Okay.
Yeah,
And
but
the
the
second
general
one.
structure, the both of them are master actually. Yeah.
Both
So
of them.
I will later on share the PhD one over here. You can see the PhD one also, but the general structure follow a similar structure, you can say. Yeah.
Okay. Okay.
Okay. So you can see from there that we have three objectives anyway. Yeah. So that's quite clear. Yeah. So we don't have sub objectives. It's not our practice to have sub objectives. But anyway, let's change your list of objectives with sub objectives, turn them into three objectives only. Then put them in the just edit them directly from the table that you prepared.
So I have to change it to 3 objectives.
Yes.
Only.
How you want to change to 3 objective in this case?
In this case, I will combine the carbon capture with the emission.
Okay.
Is that okay? Because in this case, we can reduce it to three objectives. If we put the NOx and carbon emissions with the carbon capture in one objective, because I thought it's separated, because the carbon capture is different than the emissions. Each one of them in another part, right?
Yes. Let's pull up. Let's share your screen with the POM table. So that easy for us to communicate.
Which one?
Your original POM table. So you already share your POM table before, right?
POM table. POM table. Shared.
You open in Word before, eh? Yeah, just click
Yeah.
that POM table. No, it was in the previous page.
This one, right?
No.
No,
The
that's
one that
one.
you found them after a long time.
Yeah. Let me find it here. It's better. Shared.
If you want to make it easy, yeah, this
Hmm.
important document is available in your tab. Can you see the topmost row over there? HSH post. Yes, that's why we make a tab before, yeah. So because
Okay.
this is important
Good.
document, you want it easy to be found. Yeah.
Yes. Okay.
Yes.
Understood. So
Yeah.
in this case, I will change the objective, and I have to change the problem statement in this case, right? It will be only one problem statement. But
Only
the
one
object,
problem statement for each objective. Yeah. So there will be total of minimum of 3 problem statements because you
yeah.
have 3 objectives.
Mhm. Yeah. Um, in this case, you can see here in the first, second, third. The third one, which is about the flame stability. This one it will be separated, right? But the emission optimization, this one, I think I will change it. Okay. Or this one, this
Yeah.
techno-economic. Sorry, this one, the fourth one, which is the techno-economic and carbon emission, carbon capture assessment. This one, I will separate the techno-economic and put the carbon capture with the emission, right?
You can combine carbon emission with because NOx emission is something different. Because when we talk about carbon capture, we're talking about CO2 emission only.
Actually, I have put the carbon capture with the techno-economic because the last time in our last in our previous meeting, you said that we can make a product from the carbon capture and we can sell it. And in this case, it will be related to the economic, right?
Yes, techno-economic and carbon capture assessment, that's fine. That can be just change that to objective 4, basically. So it's not sub-objective anymore. It's instead is a standalone objective, yeah?
Mhm. So this one, objective 4, it will be objective 4, techno-economic and carbon capture assessment, right?
Okay, that's fine. That's fine, yes.
That's fine. And the objective 3, which is emission optimization, it will be standalone.
What you mean by emission optimization? Are you talking about the combustor alone?
Of course, we will talk about only the combustor
Okay, only
because the
combustor. So objective
the
number
outcome.
3,
Hmm.
that means objective 3 will focus on combustor alone, yeah?
Yeah, because I was thinking that the outcome of the combustor, it will go to the first stage turbine, right? Then the NOx, it will be there.
Yes, yes. Okay, by the way, objective number 4 don't have CFD in it. In the methodology of CFD of objective 4, we don't have any CFD at all. By you putting CFD here, that's why you think the scope becoming too big, because you think that you will do CFD for every objective. It's not like that.
This is the idea. This is you see, doctor. This is the idea. Actually, that one, if you see my screen, that one who makes me be scared, because this kind of uh, discussion, it will go to Aspen HYSYS. Aspen HYSYS is the first or the best application who can handle this idea.
Yeah, but I was saying you don't need to put CFD in objective number 4.
No need for the CFD. Okay, then we'll change it. No need.
So, just say that you will do Aspen HYSYS simulation. That's fine.
Doctor, it's recorded, right? Because it's already recorded.
Yes, exactly.
Okay, that's good because I need to review this video again. No need to
Yes.
to write down some notes. So in this case, I will remove the CFD and keep the Aspen HYSYS simulation, right?
Yes.
Aspen HYSYS, it will take. Is there any ability to have some access for the Aspen HYSYS?
Yes. Because Aspen HYSYS, UTM has license to it. So if it has license to it, then you can install it, in your workstation over there also.
But how to download it?
Yeah, later on, once the time comes for you to do it, then you can. They always come
Great,
with a YouTube video or guide to install and all that.
great. That's very good. So in this case, objective 4 is okay, and objective 3 is okay, right? Am I right?
Objective 3, okay. We need to I need to listen completely from you from objective 1 until objective 4. I understand objective 4 for now. Objective 3, I'm a bit skeptical. Okay, now go to objective 2.
Objective 2. This is
Yes.
objective 2. It's about the flame stability. Flame stability
Also
analysis.
CFD. Also CFD.
Of course, it will be on the CFD.
CFD. Okay, so that's why things are getting. Okay, so now so far you just have one CFD model on combustor. Let me see what you have in objective number 1 then.
Objective 1, it was sub-objective 1. So it will be about the CFD model development, to develop and validate a high fidelity ANSYS fluent model capable to predicting reacting flow.
Okay, so that means you're talking about combustor model again.
Yeah, of course.
Okay, so that means objective, primary objective, objective
Doctor,
1, objective 2.
Doctor, I'm trying to focus about one combustor because the gas turbine, or I'm dealing with gas turbine, which is conical. I mean, we have 10 combustion chambers around the shaft. So if we can make the simulation for one combustor, that's mean we can just multiply it by 10, right?
Yes, that's fine. I was if you focus on combustion alone, I'm happy to let you do it. But now we are doing techno-economic analysis of the whole plant, yeah,
Mhm.
which may include the sourcing of hydrogen as well. Okay, so here is what we discussed last time, yeah.
Yeah.
I told you that to do CFD from scratch, then you better focus on combustion only. No need to talk about carbon capture. No need to talk about anything else like hydrogen cracking and all that. Okay.
Right. Right. We have discussed this before.
In that case,
Mhm.
here is the challenge. Yeah, here is the challenge. You have to build the model from scratch. Yeah, we don't have the CFD model that has been produced by any of our member before. Yeah. Okay.
Mhm.
If we're talking about doing TEA analysis from scratch, I'm fine with that because TEA analysis, the learning curve is not that big. Aspen HSH learning curve in general, is less intense compared to CFD. Okay, if you want to do CFD, I encourage you to use the existing CFD model that we have. Yeah,
The
I
carbon
mean,
capture one?
build from the existing CFD model that we have, which also include combustion in there because our carbon capture, interestingly, incorporate flame technology, right? So it comes with sort of combustion taking place also, even though we don't call it combustor.
Mm.
You understand? The decision is yours. I just put forward what are the challenges to be expected. So in that case, you can be the user instead of developer of the CFD model. So you use the existing CFD model that we have, take advantage of it, and then at the same time run the TEA analysis coupled with that CFD model.
Doctor,
So
previously you told me that the carbon capture model is already done in the university and we can use it by adjusting or modifying some variables. So this is another model that the CFD model about the combustion chamber.
no, it's the same carbon capture model.
Mhm.
However, our carbon capture is not the carbon capture that you wrote in the proposal. In the proposal that you sent me, you wrote about amine-based carbon capture. Those are actually conventional carbon capture. Ours one is not conventional carbon capture. We are, a new, you can say next generation carbon capture, so to say. Yeah.
Uh-huh.
So ours is not adopting the same, absorption method to do the
Mhm.
carbon capture. We do using thermochemical approach. Yeah.
Mhm.
So ours one, that's why in there itself there is a novelty, and then coupled with the TA analysis to look at the feasibility lah. But obviously you can still study combustion or co-firing of hydrogen and ammonia, but you don't do it in CFD. You do it in in much lower order model. Instead of multi-dimensional model, it is a zero-dimensional model in Aspen HYSYS.
Mm.
Yes.
Uh, Doctor, but I'm trying to avoid using ammonia cracking. No, not ammonia cracking. I'm not. I'm trying to avoid using ammonia in the gas turbine because
Mhm.
it has two variables, which is the hydrogen and nitrogen, and both of them, if I wanted to use them in the combustion chamber, it need to modify all the route. That's mean to change the design of the combustion chamber, and that's
Yeah,
not
that is actually still a question to be answered, subject to the fuel composition that we have. Obviously, mixing of ammonia and hydrogen will make the overall flame speed approaching the natural gas flame speed. Yeah, because
it will be
ammonia is
useless.
very
It will be useless from the aspect of from the financial aspect.
Because of
The nitrogen will blow off the flame, and the hydrogen will increase the speed of the flame. So both of them are contrary. I mean, I have to change the design.
yes, no, not necessarily actually, because what we have in the concept of co-firing of, because right now people are talking about co-firing of ammonia and hydrogen together. That is actually a well-established idea on decarbonization of thermal plants, right? And if you want to convert all the ammonia into hydrogen, that means the energy demand for your ammonia cracking will be quite big. But
Right.
if you just partially crack it, that means you might have 20% of hydrogen and 80% of ammonia. Yeah, you still burn a clean fuel. Both ammonia and hydrogen, they are clean fuel, and as long as you can reproduce the flame speed of natural gas using the mixture of ammonia and hydrogen, then we can save ourselves from changing the gas, the combustor altogether. Yeah, changing the design of the combustor and all that. So we're thinking about reproducing the composition of the fuel so that it can to some extent replicate the properties of natural gas.
Doctor, practically, from my experience in the power plant, the problem of the NOx is too big. That's why I didn't want it to produce the ammonia inside the gas turbine. I can show you some pictures because of what happened in the blade because of the NOx. That's why yeah, I can show you
Okay,
some
so
pictures.
that is the NOx that is produced from what kind of combustion?
Natural gas.
Oh, natural gas. Okay. Okay, for
Yeah.
your information, the NOx that produced in natural gas combustion and the NOx that produced in ammonia plus hydrogen combustion, they come from the same source, which is thermal NOx. Only some portion of it, they are basically fuel-bound NOx. So fuel-bound NOx is basically small portion. If you don't control the temperature, the local temperature, you have high temperature pockets, yeah, then NOx tend to be very high, regardless if you burn natural gas or ammonia, hydrogen. Yeah, any fuel that you burn, if your NOx reduction mechanism in the gas turbine is not properly working, then yes, you always have high NOx anyway, regardless of what fuel you burn.
You mean now the NOx which comes from the natural gas is different than the ammonia, right?
No, I am saying the opposite. I'm saying that they are the same.
Are the same. Sorry.
They are the same because they come from the air. They come from air which contain nitrogen. Yeah, so that nitrogen turns into NOx when it exposed to high temperature. So this is what we call thermal NOx. So that means If you use the same air, regardless of what fuel you burn, you get NOx. Yeah.
You see these pictures?
So
You see these pictures,
yeah,
Doctor?
yes, I can see it. Yes.
That's what's happening in the power station.
Okay. I see.
You see this kind of damage. This is not only from the NOx. This one, maybe you can see it.
Is it the holes over there, the small holes?
Which one? Which holes?
I can see in the third blade from the left, it has some holes there.
I don't know which picture you see. You see now.
Yeah, you just stop for a moment. I will tell you.
Okay, I will show you this one. This one, right? You can see
Okay.
this one.
Yeah.
Yeah, this one you can see the blade. How is it?
Yeah, I can see the holes there. I mean,
The holes,
it's like
the holes because of some particles. But I'm not talking about this one. I'm talking about the color of the blade. This one.
okay. The color become like reddish. Yeah, reddish color. Okay, I see.
Yes. That's what I
Reddish
mean.
color.
Yeah.
Okay. Okay, that's fine.
This one you can
Okay.
see this
Okay.
one.
So
Heat.
yeah. I got it. So okay. That's good. You understand the nature of what is the effect of NOx on the blades. Yeah. So that is one thing that we can put into consideration. Anyway, this POM table, we need to have a draft of it. So right now you got 4 objectives, yeah. And I already brief you what challenge that you will have to face, which is actually not impossible. With appropriate effort, yes, you can do it. I believe you can do it. So it's just let's put everything forward and then decide on one thing. If you want to go for combustor alone, let's focus on combustor, only CFD, nothing to do with carbon capture. It's just co-firing, yeah. No Aspen HYSYS, no TEA analysis, yeah. So T analysis, yes, you can do to some extent, just very shallow, you can say, but it doesn't cover, carbon capture. It doesn't cover other components. Focus
Yeah,
on combustion
it will
alone.
not cover. It
But
will not cover all the plant.
no, not the whole plant, just the combustor, not even the whole gas turbine, just combustor. Yeah. Okay. However, the success or the survival only depends on one thing, whether you can develop the CFD model for combustor or not. That's it. Okay. Okay. But then on the other side, if we make the scope to be a bit hybrid, you can say depends on how comfortable you will be with CFD. If you feel super comfortable, then you make 50% CFD, 50% TEA analysis, but your CFD will be on the carbon capture, which you will begin with the model that has been developed by our member. Yeah, it's already model. The CFD model is running and validated, but now you just need to add a few other variables and rerun the case as user, not as a sole developer. Yeah, and then couple with the TEA analysis. So these are the possibilities that we have. Decision is yours. Decision is yours. Don't worry. You decide, and then I'll try to assist along the way. Don't worry.
Thank you. But Doctor, what if I have the combustion chamber mathematical model for the combustion chamber? It will help a lot, right?
But what do you mean by mathematical model?
To be honest, I was talking with one of my friends. He was doing something about the mathematical models then he said to me that if you find the mathematical model for the combustion chamber and what we can change in its variables, then it will help a lot. But I didn't understand him completely.
Yeah, okay. Then mathematical model can mean zero dimensional. If it's zero dimensional, it basically refers to high exponences. Yeah, you can write zero dimensional just using a simple equations also. That's also possible. That is also zero dimensional model. Yeah. Okay. Then if you talk about multi-dimensional model, then you're talking about CFD. Yeah. So either you want to study flame stability, you want to study the NOx emission inside the combustor. So all that can be done with multi-dimensional model. Okay, so
So you
mathematical model
mean
can mean many things.
so you mean mathematical model, if it is zero dimensions, then it means one variable will be changed, right? Am I understand it the right way?
Zero dimensional means you can tell if you increase the fuel, then what will be the outlet temperature. If
Uh-huh.
you reduce the oxygen, what will be the outlet temperature? Okay, so this is
So
like
it
zero dimensional.
so
But
it will
if
it will it will address
multi-dimensional,
one factor, right?
no, it can address multiple factors, but you don't have X, Y, and Z. Okay. If you talk about multi-dimensional model, then you can tell if you change the fuel flow rate, what will be the temperature near the outlet? What will be the temperature at the center of the combustor? What will be the temperature at the bottom of the combustor? So this is multi-dimensional. It has X, Y, and Z. Yeah, that is CFD.
Uh-huh. Okay. Okay. Okay.
Okay,
So yeah, I
so
understood.
that's fine. We if we were to go with because this objective right here that you list this is not doable in PhD because you have a very deep study on CFD, and at the same time you try to couple with the wide TEA analysis. Okay, so if you want to go deep like this in CFD, I would say that you have to kick out objective, the last objective. Yeah,
The last objective, which is
about the TA analysis has to be kicked out.
keep out. Okay. Okay. So I have to choose either the TAA or the CFD model about the combustion chamber.
No, you have to choose between three. Yeah.
23.
Uh, 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 okay. To some extent, yes, it's two only. Yeah, it's two
Yeah.
only. One is CFD of the combustor alone. Second
Okay.
one is TEA analysis plus CFD of the carbon capture, not CFD of the combustor.
Mhm. Okay.
Yeah,
Okay. In this case, I have to make another search.
yeah. No, I mean I'm saying that if you want to go with TAA analysis, it's good that we tone down our CFD difficulty by using extending from the existing model. Yeah, if you want to go for combustor, yeah, we have to go with the combustor alone. Yeah, so in fact, uh, there is one combustor geometry that we developed before that is real geometry. Since I'm not an engineer who work in power plant, I just hear from what the power plant operator says to me. He said that this combustor geometry is belong to MHI. Okay, another person say no, it doesn't belong to MHI. It belongs to what was it, Zeeman. Yeah. whatever it is, it's a real geometry. Yeah. You know, you can have a look at that, but if you don't have experience of CFD, I don't encourage you to look at it. If you already have some experience with CFD, yes, I can give you the model, that model, you can have a look. It's very complicated to handle that model, because even though it's just a combustor model, but it's very complicated because this is real geometry, including real blades, you know, real shape of the combustor, and we did it with natural gas as fuel before. You know, but anyway, if you want to go with this, if this is not the same combustor that you have in the plant, then you might not have access to all the OEM data for validation purposes.
I'm trying to generalize my work. I mean, I'm not talking only about the frame 6B, which I have in my station. I'm trying to talk about all the combustion chambers, all the which they have the same shape.
If you
The,
want to
the,
talk
the,
about all combustion chambers, that is an interesting topic, but it will not be doable with full CFD version. You have to tone down your modeling approach by adopting zero dimensional or something like that. Okay, so I have another 5 minutes to be with you. Let's you know, don't be rushed. You know, it takes some time to read. In fact, you know, I expect us to discuss about key paper. You want to address any key paper that you already read? You want to tell me the story, what you found from those papers?
which you mean the papers that I have addressed or what?
The paper related to the problem statement. What we supposed to have in this left column called problem statement, we should formulate the problem statement based on the research gap that you found from the literature.
Yeah, I have some papers. Even I addressed them here in this file.
You haven't put them in Mendeley yet, yeah?
Actually, I have. I wanted to tell you about something else, but it seems the time is not enough. Because each time I change the. Can you give me more than 5 minutes?
No, I have to go now. I mean, after 5 minutes, someone is waiting for me.
Okay, okay.
But obviously,
I will write everything for you and what I have faced on my search. I'm falling in I think they call it the rabbit hole, because each time I change a word in the title or the objectives or the research question, I have different papers. But this time, I think I have, after your approval, because you said that the title is good and the research questions are good. So I will keep these references to build a new problem statement and not objectives, the problem statement at least, and the gap and the scope of work.
yeah, so you can pick just one paper. Maybe you come across one paper that you discuss, you already read thoroughly. You want to discuss with me, and then you want to identify, oh, this paper showing that, you know, there is a research gap in certain areas of the co-firing CFD study, you know. So that is the one that can be addressed by objective one. That is an example, lah. Yeah.
Actually, this is I made a table for the research gap. How did I find it?
Yeah,
And
okay.
how
Just among this, you just select one and then tell the story to me. Okay, you have how many? Let's say you have 5 on these pages, right? So pick one paper and then open that paper. Just show me some plots or anything like that, you can
This is
brief me on.
Yeah, the paper. It's paper 7, for example. Paper 7. That's one. That one. It was talking the title of the paper. It was talking about the CFD study of the combustion and emission characteristics of methane hydrogen co-firing and environmental analysis, environmental burner.
Okay, this is I would say couldn't be a key paper because the scope is quite far away from yours. The scope of this paper is basically on EV burner. What it means by EV burner?
EV burner, which is the environmental burner, because I have made my main objective or the goal for the project is the environmental friendly burning, okay, and the cost reduction to produce the electricity. Because the NOx and carbon emission and the carbon capture, all of them around the environmental, right?
Environmental EV stand for environmental burner.
Yeah.
Okay. What is the environmental burner?
The environmental burner is, I listed here.
Is it for power plant or is it for what?
Yeah. It refers to an environmental burner, a gas turbine burner combustor configuration used to study methane and hydrogen co-firing flame structure, a flashback tendency, and NOx emission.
Okay, so okay. Then if this is the burner used in the power plant, yes, this is relevant. Okay, go ahead. You can continue your story.
Yeah, so that's why I chose this paper, and I have another papers for the gap. I mentioned them here in this table. This one. The first one was because extracted from the paper 7 and 25, 21. 21 is this one. This one, the experimental and numerical study on formation and NOx emission of hydrogen enriched methane combustion in a swirl flame and mild modes. This one, because of the enrichment for the natural gas. That's why I chose this one.
Okay, so what is the? Oh no, you now you change the paper already. We should finish the first paper first, the EV burner.
Yeah. EV burner, this one. Yes. What do you want me to?
Yeah. So what is the research gap that you found here? So far, maybe first, what is the main findings from this paper, and then what is the research gap that you can contribute further?
Yes, I address it here. This is it. The one this one research gap component is it's needs for CFD model to develop the validation. The study how to support the gap. I mean this paper how to support the gap. That's what I mean here. It says that using CFD to study methane hydrogen co-firing in gas turbine, environmental burner, and analyze mixing temperature OH distribution and flashback and emission using CFD NOx chemistry analysis for hydrogen enriched methane combustion. These support
Oh, so
the
that means this paper study the flashback, yeah?
yeah.
Okay, so how they study the flashback here? They might use transient simulation somewhere. Are they working on transient simulation or steady simulation?
Study simulation.
For steady simulation cannot study flashback. For flashback, you can only study it with the transient simulation.
Only transient.
Yes.
One.
Where is that EV paper? Where is that EV paper? You're talking about EV paper, right? Lee.
Yeah. The paper 7.
Yeah, you need to quickly use Mendeley, yeah, because otherwise your experience with literature review will be very tiring. Okay. So where is that result on flashback? Any plot on flashback here?
This one for the EV burner description and operating conditions. This one.
Yeah, no, but I want to see any results on flashback, because that's what was mentioned in the table that you showed previously.
Right. This one for the EV burner and yeah, it talks about the phenomena of the flashback.
Yeah, but where is that flashback?
This one.
Yeah, here.
Yeah, this is the picture of the flashback.
Okay, so definition of flashback, OH radicalism for each case and flashback regions with normalized OH value greater than 0.7. Okay, so that means they have this flashback being reproduced in the CFD. Okay, that's good. I mean, and I believe they're doing the transient simulation here rather than if you want to model flame lift off, yes, you can still do it with the steady simulation. But for flashback, it has to be in the transient simulation. Unless if they define flashback differently. If they define flashback differently to some extent, if flashback is something that is a steady occurrence, so that means the flame don't propagate upstream, yeah, continuously, then yes, maybe they can model using a steady simulation. Okay, if the flame stay like shown in the picture on the left, yeah, so then yes, it's possible to do the process. And this burner, I mean, they have good result. I mean, good experimental data, yeah. And if you use their data and develop the same geometry, then this can be also validation data for you. But it depends on how complete the information is.
Actually, this paper, each time I change the question, it appears. That's mean this is a core paper. Some of the papers, it keeps appear to me in the search. So as a result, this kind of papers, it will be a core paper, right?
Yes, this can be one of the key papers. Yeah. So this is what. So the statement that you wrote over there just now is not simply a gap. That one is like the first sentence is explaining what the study has done. Yeah. It studies about flashback, Knox chemistry. Please, please don't move. Please stay on the same page.
This one?
Yes. Okay. So the first statement that you wrote about paper by Lee is basically telling what Lee has done. Yeah.
Yeah. Right.
Okay, and then you relate Lee with another paper by Zhu. Yeah.
Right.
But here they do not fully connect CFD to carbon capture and full techno-economic feasibility. Okay, yeah. So you see that, right? So
Yeah.
that means people who do this is, I would say, very deep CFD study. When this is a very deep CFD study, then it's not easy to couple them with with the techno-economic or carbon capture study. Okay, so in the next
This one is
week,
talking only about the CFD.
yeah. Okay, so next week, this is what we will do. For next many weeks. Oh, actually, next week I will not be around. On the 8th of the week of 8. I will not be around on Friday. So we'll meet the Friday after the next Friday. Yeah, inshallah.
Okay.
And that is next when we meet. Why don't you try to find one key paper that has a coupling between CFD and TEA analysis? Maybe you can find, you can assess how deep the CFD study that is coupled to TEA analysis. Yeah. So then, it will be interesting to discuss that kind of paper also.
Okay, Doctor, I also wanted to ask you about something. When I make the proposal, do I need to collect the information from all the papers, or only to have maybe 10 or 30 papers? How many papers for the proposal?
I don't have any specific number. It's just we need to come up with research gap identification that is enough to support our objective. Yeah.
Which comes from the primary question, right?
Yes, it comes from the problem statement that we have.
So the problem statement, it will come from the primary question.
I don't know what you mean by primary question. Is the primary question the only question that you have for the whole project?
Doctor, from the title, I have extracted one primary question. Okay, then I have extracted sub questions from the primary question. That's
okay.
why
I think you're
confused.
talking about that because you're talking like that because you haven't gone through a sample thesis. Yeah. So
Right, exactly.
Okay, that's what I want you to do next is to read through the thesis in the training folder. So that you know how we work. Yeah. Normally we don't have like one primary question. We have 3 primary questions. Yeah. So there will be one primary question for each objective. Yeah. So you read through that thesis, you understand how to communicate in the thesis. Then we come back to our POM table and key papers. So every week we will study like that. And in the normal practice, 3 semesters are taken to finalize the proposal. So no rush. Yeah. So 3 semesters are taken to finalize the proposal. Sometimes half of the semester is just to finalize the POM table, but it comes with extensive literature review. So 1 month of literature review can save years of work. So so you better do the literature review properly, and you will be exhausted if you don't use Mendeley.
Yeah, I'm using Mendeley. I will use it.
Yeah. Okay.
Inshallah.
Okay. I'll have to leave now. Yeah. Inshallah, I'll see you next meeting. Yeah.
Inshallah.
Assalamu alaikum.
Inshallah. Assalamu alaikum.